Jacobi method. So in this method we are going to solve the equations, these three linear equations by Jacobi method. So first of all, let's number these equations as number 1, number 2 and number 3, and for convergence we have to check that the diagonal elements, these are greater than the other two elements. In this coefficient should be sum of greater than sum of these two elements. So 3 the mode should be greater than or equal to 2 the mode plus minus 1 the mode, that is 3 is greater than or equal to 3, so which is true. So first equation is suitable for the solution. So for second we will check this coefficient 1 the mode should be greater than, diagonal element should be greater than 2 the mode, this mode plus 4 mode. So that is 1 is greater than or equal to 4 and 2 6, which is false. So second equation is not good for convergence. So third equation, in this equation diagonal element, this is diagonal element 2 is greater than or equal to this coefficient plus this coefficient 1 the mode plus 3 the mode, that is 2 is greater than or equal to 4, so which is false. So it means equation 2 is not at right place and 3 is not at right place. So we will interchange these two equations, equation number 1 and equation number 2. So let's say equation number 1 is good, that is 3x plus 2y minus z is equal to 7, and for in place of second we will use the third equation, that is x plus 3y plus 2z is equal to 12. So now if we check this, the diagonal element, this 3 is greater than or equal to sum of these two elements. So in this case you can see 3 is greater than or equal to 1 plus 2, that is 3. So this is true. In third equation we will write this 2x minus y plus 4z is equal to 13. So now to check this, 4 mode is greater than or equal to 2 mode plus minus 1 mode, 2 mode plus minus 1 mode, which is 4 is greater than or equal to 3. So true. Now these three equations are good for convergence, 1, 2 and 3. So we have to arrange these equations as this as number 1, number 2 and number 3. Means diagonal element, diagonal value should be greater than the other two values, sum of other two values. So this is greater than these two values, this is greater than these two values, this is greater than these two values. So now from these equations we will calculate the value of x from this, that is 7 plus 3z, 7 minus 2y plus z over 3 is value of x. From second equation we will calculate the value of y, 12 minus x minus 2z over 3. From third equation we will calculate the value of z, 13 minus 2x plus y over 4. So now onward we will use these three equations x, y and z to calculate the value of x, y and z in Jacobi method. So iteration first, we will calculate, first of all take x equal to y equal to z is equal to 0. We always start from 0 values, and if you take these you will get value of x as 7 minus 0 plus 0 by 3, that is 7 by 3, which is equal to 2.333, and y you will get 12 minus 0 over 3, that is 4, and z you will get 13 minus 0 plus 0 over over 4, which is equal to 3.25. So these value will be used in the next iteration, that is 2. So take x is equal to 2.333, y is equal to 4, z is equal to 3.25. So x is equal to, we will calculate by putting these values. X is equal to 7 minus 2 into value of y is 4 plus value of z, that is 3.25 divided by 3, which will come out to be 0.75, and value of y 12 minus x 2.333 minus 2 into z, this value 3.25 divided by 3, that is 3.167, and z is equal to 13 minus 2x 2 into 2.333 minus 2 into y, that is 4, and divided by 4, this comes out to be 3.0833. So these value of x, y and z will be used in the next iteration. Iteration third, take x is equal to 0.75, y is equal to 1.0557, and z is equal to 3.0833, and put these values in this equation, and this equation, you will get a new value of x, y and z. So you will get x is equal to 2.6574, y is equal to 1.6945, and z is equal to 3.1389. So these values will be used in the next iteration, which is iteration number 4. So in 4, take x is equal to 2.6574, so y is equal to 1.6945, and z is equal to 3.1389. So put these values in these equations and get value of x, y and z. X is equal to, you have to put these values, x is equal to 2.25, y is equal to 1.0229, and you will get z is equal to 2.3449. So these values will be used in next equation, in next iteration, that is iteration 5. Take x is equal to 2.25, y is equal to 1.0229, and z is equal to 2.3449. So put these values in this equation, you will get value of x as 2.4529. Put these values in this equation, you will get y is equal to 1.6867. put these value in this equation, you will get value of z as 2.3807. So we have got these new values. Now use these values for the next iteration, that is iteration number 6, and take x is equal to 2.4529, y is equal to 1.6867, and z is equal to 2.3807. So put these values in this first equation, you will get a value of x as 2.0024. Put these values in this equation, you will get a y as 1.5952, and put these value in this equation, you will get z as 2.4452. So again, you can use these values for the next iteration, which is iteration number 7. So take x is equal to 2.0024, y is equal to 1.5952, and z is equal to 2.4452. Put these values in this equation number 1, you will get x as 2.0849. Put these values in equation number 2, you will get y as 1.7024. Put these values in equation number 3, and you will get z as 2.5288. So again, you can use these values in next iteration, and similarly after doing that, you will get values as iteration number 8. Take x is equal to 2.0849, comma, y is equal to 1.7024, z is equal to 2.5288. Put these values in equation number 1, and you will get value of x as 2.0413. So as you can see, the value of x you have achieved up to 2 decimal places. 2.0 is same, 2.0 is same. So if you want a value after up to 2 decimal places, you have got the answer. Similarly, put these values in equation number 2, and you will get value of y as 1.6192. Put these values in equation number 3, and you will get z as 2.633. So you can say we have got our answer as x is equal to 2.04, y is equal to 1.62, and z is equal to 2.63 as solution. If you want answer correct up to 3 or 4 decimal places, then you have to do more iterations. So it is a little bit lengthy method,